Hello, hello, and happy New Year's to everyone. As we start off the year, I have a different kind of presentation to follow up on the last few. We're going to go technical today, but from a structural organizational perspective, talking specifically about AI assisted coding practices and how to achieve much better AI assisted coding speeds and consistency than I'm seeing typically going on right now. This is from a lot of our personal experience and learning. It is very time specific in the nature of things, meaning in the future, a year from now or 6 months from now, this video may not be as relevant anymore. So this is, the nature of things because things are developing quickly. But I want to make sure first that we're clear about what we're talking about. So AI assisted coding is coding where a programmer, so not a non-programmer, but an actual developer, is leading an AI assisted or co-pilot kind of function with an AI that's helping them to code or supervising the code. What this isn't is it's not a vibe coding or one-shot coding. So what is one-shot coding? That would be maybe you're not a programmer, you write an instruction about what you want to have it build, and it goes off and builds a whole app for you in one go, and you just look at the results. And then vibe coding would be maybe you take that initial first code that's been created, the app, and conversationally you ask the AI to improve it and to make it better, right? But you're not actually really looking at the code. You might not even be a programmer. So this is not what I'm talking about. I'm talking about an actual programmer using AI to accelerate their process. So there are a lot of initial appealing benefits to this. The AI has a lot of knowledge. It writes code at insane amounts of speed and volume. You can use the AI to analyze log files or data sets and get very quick analysis and assessments of them. The AI can give you ideas on edge cases and issues that you might miss otherwise or think about them. And when it's working, you can get really well structured code. You can also get really good inline comments, maybe to a level that would take too much time to do before. So, the lazy coder doesn't want to create inline comments to that degree. And, you can also make it do really good documentation of the resulting project or upfront. But, I have here a couple slides of problems, so there's all kinds of issues, and these come to light the more you use it. So there's all kinds of issues with memory. There's issues with context drift. So what I mean by that is if you type into your AI and you give it a really good idea of the code and your problems and what needs to be done, that moment in time is when it has the most context. And then the more you talk to the AI afterwards in that conversation, the more it's going to drift away and start forgetting things or start focusing on the wrong thing. Or you might give it too much information and then it's going to focus on the wrong little piece of information that's actually important. But, AI is also extremely confident, and that is kind of a false confidence. It will say it's fixed a bug when it hasn't even checked that it's fixed it yet. It can get easily distracted. You can distract it very easily by just giving it a prompt with, you might say something wrong and then you derail it and it says, oh my God, that's a great idea. And also sometimes it cheats. It tries to find shortcuts into things. And also it writes code at insane speeds, which means it's really hard to read. And, there's other issues here. Let me see if there's others I haven't talked about. Yeah, you get some inconsistent results. I already talked about the over-influencing, verbosity. It doesn't learn. There is no real learning. Yes, you can take information and you can store it into documents and you can reference it, but you're still building context every single time, especially if you're using a platform like Cursor or something like that. It doesn't really have a goal as well. The goal is really you. You're the one deciding which way to go. And so that has all kinds of problems because if you're trying to use the AI to help you write the code, you have to be really driving it. And, the lack of methodology built into the system, it really becomes a problem when you're trying to just iteratively create the code. So, why are we even wanting to bother? Well, if anyone's tried to use AI to create code, especially from scratch, you get this kind of like ridiculous speed up front, and then it kind of tapers down. What I've been seeing internally, other agencies, and reading online, there's kind of this commonality benchmark right now where you should be getting at least 30% benefit from using AI to assist you in coding. That's the floor. What I'm actually talking about today is how do you get above that 30% speed boost? So a lot of it feels just within reach. And we've had over the last month period, especially a lot of lessons learned and really kind of grinding through all these problems. And we're finally really finding out how to like crack this. So when it works, you're getting dramatic speeds at that like above 30%. You get to focus on the higher order problems. So you're not busy just, writing lines of code one at a time anymore. You can also learn entirely new skills and become an expert in something new because you have the AI that can really help you. Another company person I was talking to, they've been using something similar to this to learn about combustion engine mechanics. We internally just did a hydraulic simulation, which is the example I have in this presentation. And that's something, that we didn't know how to do hydraulic realistic scientific simulations. So this was like a really good candidate for using this kind of an approach. How do you write that code and have it work and not take, months of coding to get it to work correctly, which is like what it would take in the past. So when it's working, you're going to get better code, better commenting, better documentation. It also is motivating when you're coding with AI. It feels like you're coding with someone else. I know it's not real, so to say, but it still has that feeling. You're also getting a good dopamine hit every single time it works, which can be sometimes the negative of it, right? Like the slot machine. But when it's really working, you get that. It's very motivating. And then if you're following really good practices, you can really apply a really strong methodology, which will allow you to, for example, log things at very high levels of detail and then get the AI to assess, analyze those large log files to make sure that every single edge case and permutation is being checked and that everything is self-consistent. And finally, last few things, you get to manifest things that you get to go faster from idea to realization, and being able to go quicker between those things on topics that are potentially new, but you have the right methodology is really rewarding and satisfying. And then, also if you're thinking about security and maintenance up front, because you have to be thinking of it, but when it's working, you get the AI to think with those things through with you as well, and you get better results because you have an extra opinion on these things that is, has a lot of insights. All right, so how do we make this actually work? So the first thing I want to talk about here is a control architecture. This is kind of at the heart of it. So instead of using one AI for the entire coding and you're using that one AI in a continuous prompt, what we're doing here is we're splitting it up. You have different AI agents doing different jobs. On the next slide, we're going to see there's mainly 3 tiers of thinking. There's the senior level. I'll go forward for a sec. There's the senior level thinking where you're thinking about the planning, the documentation, the design patterns, best practices. There's no code being done here at the strategy level. You're also combining it with real documentation that is going to exist that you can pull into the project as well. Then you have another model that is the manager one, which is going to delegate, create job descriptions for what needs to be coded, and then the actual developer that's going to write code, self-validate its own work, validate the approach that's being given to it as well, so that we can have pushback. And this really, some of the benefits of this is that it keeps the context of these 3 conversation layers separate from each other. So you're not littering strategy into the developer talk, and you're not littering developer talk into your strategy conversation. You keep those context windows very clean, separated, and then you have process between them in order to manage that flow. So going back to this slide, the log proofing is the next thing that we're going to be also talking about here. So you want to be able to prove that the code is working and then have the AI validate using the log files that it can see itself that everything is error-free. So you need to be taking that kind of an approach that things need to be proven. And then we're also doing a process where once things are broken down into steps, step 1 not only proves itself, but it proves that it has everything it needs for step 2 to be successful before we even start step 2. So I already talked about this, the memory management, the reduction of drift, and because this will give you a lot more mileage with each of these conversations before you might need to do a reset, because at some point the conversation just gets too long. So how this looks in terms of a flow, so you have the strategic plans that are done, then you have the manager who's passing things to the developer, and you've got some iterative loops until things are ready to review for the next phase, the senior AI strategy layer. These are all AI agents, by the way. This is the humans guiding it through, but it's all AI steps. And then the last step here on the right, the senior strategist does a final review and audit, validates, and gives recommendations of things that it's seeing need to be paid attention to in as things go on to the next phase. So a lot of the emphasis is on upfront documentation. Make sure that you have the specifications defined. If you're doing something based on a scientific model, get those original scientific papers, load them in as PDFs into your strategist to make sure it understands the theory that we're going to be applying into code. Make sure we're creating all of the design patterns up front. We've got that all documented. Just tons of documentation up front. This is really good practice with software development in general, but the emphasis is even higher with this kind of an approach of an AI-assisted coding practice. If you've got things that need to be built like back-end code, database, front-end code, what are your best practices? What are the code frameworks? If you've got a very custom API that you need to connect to, find that documentation and add it into the strategy planner's knowledge or into and also the developer's knowledge so that these systems are aware of the actual API calls they need to be writing towards. So the more documentation you can do here up front, again, we're trying to keep the layers separate so that the strategist is getting more of the strategy documentation. The implementing developer, you don't need to overload its context with all of that knowledge. You really just want it to focus on writing the code. And I did kind of go quickly on this, but the other advantage of having a strategy layer and then a development layer as separate agents is you can use a much lower cost agent to be writing the code. So in our experience, something like Gemini Flash or equivalent is low cost, but still performant enough that it can get the job done without cheating, because sometimes AIs will cheat or make mistakes if they're too small a model. And then you can have a much higher powerful model doing the strategy and the assessment. It needs to understand a larger context window. That could be Opus. It could be one of the top of the line ChatGPT models, or it could be Gemini Flash Pro with the thinking enabled. There's lots of options there at the top end. And sometimes you need to test based on the topic that's being done, which model is going to be the best at the strategy of it. We found that even though some models benchmark very close to each other on benchmark tests, that doesn't mean that both models are good at very specific topics. So for the hydraulic simulations that we did, for example, Gemini Pro with the thinking mode on really was so much better than Opus. But on a different project, Opus might be better. So you do need to do a little bit of research there as well in this planning phase. Okay. Next technique, work from big to small, paint broad strokes, then work on details. That really reduces your risk. If you want to start off with this kind of approach, this is the way to think about it to get going. So what does that mean in practice? You have you're documenting all of the different interactions of the structure of your code. This is it looks like an org chart, but imagine that this is like a diagram of your design patterns and your classes and their interactions between each other, like a UML kind of diagram. So you have the developer, so you've built that all out, and then you're giving it to the developer AI agent, and then the developer AI agent just writes the one class up to the specifications that it's been given. You then ask that developer agent to log all the information that it needs itself to prove to the manager AI that it has completed the job. So it self-checks itself and makes sure that it agrees that it's done everything. The manager will then review all of that, give feedback. Maybe it's a win. You're moving through. If there's anything the documentation needs to be updated, you want to be updating the documentation at this point because you don't want drift between what the documentation says needs to be done and what was actually done. And once that's all done, manager passes on for the AI developer to work on the next class, the next component or system, whatever it might be, or an implementation of a pattern, right? If you have a factory pattern, maybe the next step is creating 20 instances of that factory pattern. Whatever that might be, that next step is then completed and you keep going. So for maintenance of documentation, I want to touch on here that there can be such a thing as too much documentation for sure. Because these context windows are so easily corrupted by too much information, you really want to keep it very focused on what is important. So sometimes you ask an AI to start creating documentation and it will just document everything. It'll be like, oh, I did this bug fix and this is the things I changed. And it writes like a 30-page book on every single update it does. You don't want that. You want to be, if you're going to be updating documentation, you're updating again that core documentation that's talking about how things are being built, not how things were changed in these iterations, and keep it really like really efficient, correct, accurate, and as minimal as possible, but still as useful as possible. So there is like an optimal level there in documentation that you're trying to aim for, you're trying to achieve. So for the prompting and the reprompting, you want to establish the role of each of these agents. You want to do that with as few words as possible, again, because you want to keep that context window really focused. And you want to upfront let your AI agents know about things that they need to be aware of, things that you're expecting, things that it can't see because the AI has no visual optics. If we're, in our case, we're building a mesh topology with hydraulic systems in it. It can't see that unless you give it a screenshot. And even then, it might need help to interpret those screenshots that you're giving it. So you want to give as much pre-information as you can in terms of scaling, in terms of what they're building and so forth. But you really want to assume this very smart person, the AI, it's their first day on the job every single time you're talking to them, and they have total amnesia of what they've just done before or yesterday or whatever. Like you really have to assume, you keep having to assume that as you're working with these systems. So here's an example of a prompt. This is at the beginning of a phase 3 step within this multi-phased project. And in here, I wanted to show an example of a prompt that has some of our lessons learned about the things that are important to be telling the developer before it works on the next step. And we're repeating this at every single step very similarly over and over. So we're making sure that the AI system knows that it's going to be logging, that it's going to be logging ahead, that it's what does the terrain look like so that it doesn't make incorrect assumptions about what the hell it's building and what it looks like. And and then we're re-referencing documentation so that it knows what it should be doing and what phase it's in and so forth. So what is, in practice, as you're working with these systems to guide them, make sure you're reading the code, make sure you're committing as often as you can because rollbacks do need to happen sometimes. Take it slow. So the thing that's kind of cool with this validation approach is even though it might sound insane that you're having the developer check the logs and self-check everything, and then the manager checks it again, and then the strategist checks it again, that's like, wow, that's like over the top validation of logs and code over and over. It goes so fast with the AI. So you can afford a much higher level of resiliency and obsession on process because even with that process obsession, you're talking about minutes. So it really is worth a highly obsessive process. So measure twice, cut once philosophy applies here. It might even be like measure 3 or 4 times, cut once, especially if you're dealing with an implementation step that didn't work right. Get second, third opinions on that. You might even bring it back to the strategist to come up with their own independent theory on the problem, and then compare that to the theory that was developed by the developer themselves when they saw that they had a bug in their own code. You also need to know when to back out. You need to proactively check that you're not getting stuck into fix loops or fix bugs. So a fix bug these are terms I've come up with, maybe they're not industry terms, but a fix bug would be you fix something, but you create a bug. A fix loop would be you fix something, but you break something else. And then the AI fixes that other thing, but then it breaks the thing that was working in turn. So you're just ending up in this loop. Sometimes it's like a triangular loop, but there's loops that you can end up in if you're not being very attentive. You can also have unwanted deletions, cheating. You can have code that is incorrectly implemented, but then it gets ingrained into the AI's memory that this is how you should do it. And then when it writes new code, it always thinks that the existing code is 100% perfect. So if it writes more code and some of the existing code was wrong, it will reference its own code that was wrong and start to re-implement patterns or its own understanding based on those false assumptions. So you really have to be paying attention to catch these things right away. That's the most important thing. But if you're not, back out, right? Don't be afraid. It's interesting because for a human, if you go into a dead end and you feel like, oh God, we're getting into feature creep within a bug fix, and how do we recover from the situation? For a person, that can be really hard. So you end up pushing through it. But with AI, it writes code so fast that the cost loss of rolling back, getting a better methodology, and then going forward is so much lower than it used to be. So it's kind of a reframing of where the effort is. So don't be afraid to roll back, basically, and go back if you need to. So let's see, anything else on this page that I want to talk about? Reminding the AI of critical focus, I already talked about that. And then you do want to permit the developer, and I mean here the AI developer, to question instructions and push back where necessary. And it's important to remind the developer that even though its role is to implement the code, that it does have authority to do this. You just have to explicitly give permission to the AI on the things that you want it to actually do. And you have to be very explicit in everything, right? More explicit than you would be with a human being. So also in your repetition of these things. Okay, so in practice, this is another step, but now this is looking at how you might bring the things back to your senior AI model. So here we have the logs that are proving the code that was modified. And because we're in this iteration of our learning of these systems, we're using, so this is a totally different chat instance, and this is the in our case the Gemini Pro Thinking, and we basically say here's the phase three, analyze the log, have we completed it, and then is there anything that is different compared to what you were expecting to see, and you get back a very long analysis and even recommendations on what should be done now based on this log file for the next phase. And then this is the feedback example of taking it on to phase four. And so below this little line break, this is the portion that the developer pulled out from the senior AI's analysis that we just saw on the last page of the things that the senior AI agent wants the developer agent to really focus on for its next phase based on what it saw in the progression of phase three. So in this case, it's targeting things like water distribution volumes and bottom-up sequential filling and things like that. So this is really helpful. This really helps the developer agent to stay on track and stay focused on things that could go wrong, and kind of reminding the agent on best practice on these things. So yeah, going into the example of the results. So here we have a hydraulic system that we've been building and modeling. And with this approach, we've been able to, so for just the hydraulic system, so the terrain mesh was already designed and developed not using this improved system. So it took a lot longer. But with this improved system now being applied with the multi-agent to the hydraulic system, we're able to create 5,000 lines of code approximately, and it's about 15 different class files that are in that collection to do the hydraulic system. 9 phase steps, took about 12 hours to do. We only found 3 bugs. Well, we meaning the developer and the control agents found only 3 bugs. Combined, those only took 30 minutes to fix, and they were fixed and then they were done. There was no like fix loops or problems or anything like that. And everything is super self-validated with these log-driven proofs. So, but what did take time was that we did about a day of planning up front. That was the most time-consuming part of it, to get all the documentation and the frameworks all done, reviewing things, also some research that people are doing to make sure that we've got all the right infrastructure and framework and scaffolding in place. So, if you add that all up, it's about like 18 hours of work, not counting on here the non-work time, right? Conversations, management time, whatever. But this is just like pure like creation time. And, maybe that would take like 3 to 4 weeks for a senior developer traditionally. So now, even though the thing that's really interesting is the person on our team who's developing this is not actually writing any code, even though they're a senior developer, but you do still need a senior developer because they need to be thinking at that level. So you're thinking about, the process, the documentation, the methodology, all the upfront research, the supervision, and then helping to do code review, validation, making things don't go off track, and continuously providing that extra additional guidance to these AI systems, and also selecting a lot of prompt engineering, because selecting what are the key things that we need to be passing between these different systems. So if we look at how this comes in, looking back and now at this model approach of how we're working, so you're not getting that ridiculous speed instantly because we're doing all of that upfront documentation and planning that before you get to the coding speed. But then once we started letting the developer loose and going through that iterative loop, it was so impressive how fast we went through all 9 phases of the actual implementation. It was just zipper fast. And so you're kind of hitting that ludicrous speed after, you drive in and then you maintain that really fast, high productive output burst once you actually get going. And this kind of a multi-agent approach with really limiting the context windows for each of the agents really helps to also reduce a lot of their weaknesses that these AI systems have, and also optimize the costs that you're spending on AI to implement these, plus less human time to code these things. So right now, we're still doing it very manual. It's not that sophisticated between these different systems. So a human being, the senior dev, is taking prompts and results and moving them back and forth between the agents. But as we refine this thing, I can see us and you listening to this building a network of agents that in the end maybe that whole flow between the senior, the manager, and the dev could be looping on its own. And maybe at a certain point, instead of it being human in the loop, meaning human who's helping to kind of connect the dots between the parts, there can come a point where you're just on the system, not in the system, and you're overseeing the whole thing, and it's just going off and doing that 12 hours of coding I talked about for the implementation of phase 1.9. It was so smooth that that could have theoretically just been happening in the background while you go off and do something else for those 12 hours, and you come back and the thing's just done. So that can be I think that's the future of where these things are going. And then, the other thing that is also going to be happening, in addition to maybe us and you who's looking at this, building these kind of agentic networks, there's also just going to be these AI systems are going to keep getting better and better and better and better and be able to do more and more on their own with a lot of those problems resolved. I think memory is really the biggest problem right now, but once that's better managed by these AI agents and they're able to learn like real learning, you're going to get the all boats rise effect, and this presentation won't be as valid or as useful at that point. But that's it. So thank you for watching this presentation, and I hope you got some interesting ideas or insights from this and this methodology. We've been really impressed with it. So let us know if you have a different approach, if you have feedback on this, if you found an even better way to get these kind of structures in place for achieving these speeds. And of course, if you want my help, ideas, insights, or whatever on this, I'm very available, like easy to reach. So you can always reach out to me. I'm more than happy to talk through anything that you're struggling with or ideas you have or challenges. So yeah, thank you so much for watching and have a great start of your year. All right, take care. Bye-bye.